Hello everybody, today we are going to do derivative review. So you guys can go download the file in the description. So far we have done integration and also series review. And today will be the derivatives, right? And this time I will work out all the steps for you guys. And let's just go ahead and get started. These questions are from my 100 calculus, 100 derivative video. So you guys can go watch that as well. Alright, anyway, here we go. And let me know how the iPad is working out for you guys, right? Because I want to work out all the steps for you guys. So let's see. Anyway though, start with number 6 from my 100 derivative video. Here we go. Right, we will be differentiating 1 over x to the 4th power. So let's start with an easy one first, right? Not like super easy, but not so complicated. So for the people who are here, please contribute. What do you think with this? And again, if you want to see all the questions, I have the file in the description, and all the questions are from the 100 derivative video. All right, so for the first one, 1 over x to the 4th power, before we can use the power rule, make sure we rewrite it. We have to get x to the negative 4th power, right? So this right here is the same as taking the derivative of x to the negative 4. Then you can bring the negative 4 to the front and then minus 1. So you end up with negative 4x to the negative 5. And you can bring this down to the denominator. Negative 4 minus 1 is negative 5. So be careful with that. So this right here gives us negative 4 over x to the 5th power. So it's a very nice warm-up question. And now let's continue with the next question. And the next question I have for you guys is this one. Question number 12 from the 100 derivative video. Okay, so this is number 12. We are going to be differentiating, and then we have secant to the 3rd power of 2x. So I'll pause for a little bit. If you guys want to work that out in the chat, I can see your messages. So go ahead and do so, go ahead and try it. I know typing this up is not so easy, but I'm looking at the chat. Chain rule, no use up, just chain rule. Perhaps this right here will be helpful. Rewrite the 3rd power here as the following. We'll be differentiating. Here is the same as parentheses secant of 2x. And then close this parentheses raised to the 3rd power like so. So let's just focus on this question now, right here. Yeah, all right, let's continue. Bring the 3 to the front and then minus 1. This is that we have a box to the 3rd power, right? We have this box raised to the 3rd power. So differentiate that first. So perhaps I will do it like this. You see that we have this box, that to the 3rd power. So bring the 3 to the front and minus 1. So we get 3. And we keep the same box. But when you write down the final answer, don't just put down, do not put down the box. Write down parentheses, and then you write down the inside, which is secant of 2x. And then remember, subtract the 1, so we have the 2nd power. Now, take the derivative of the box. So just ignore the 3 on the outside now. The derivative of secant is secant tangent. So you are going to have secant. And be careful though, inside here we still have another box. So secant of the same thing here, and also tangent of the same thing, 2x right here. And then finally, multiply by the derivative of the 2x, which is 2. So multiply by 2. So it's a chain rule twice question. And for secant, it's trickier because you have two parts, right? The secant and also the tangent. Finally, we can just put them together. So we can see 3 times 2 is 6. And be careful. Here we have secant 2x to the second power, and then secant 2x and then to the first power. Combine them, we can say that's secant to the third power of 2x. And then finally, we have that tangent of 2x. Yay. So just like this. So make sure you know how to do the derivatives, all that for your Calc 1, Calc 2 classes. This is actually for Calculus 1, but of course in Calc 2 you also need to know your derivatives. So I'll pause for a little bit. If you guys have any questions, you guys can leave in the chat and let me know. And for the people who got it right, yes, you did it right. Nice. Oh, be careful. It should have been secant to the third power because secant, this is second and then one more power. So together should be the third power. And then also be careful, you have to multiply by the derivative of the 2x, which is the 2. So assuming for you guys. Aha. I think this right here is more clear. That's why I decided to use the iPad today. And let me know how do you guys like this format. Done? All right. Now, I think I have one more space for the next question. The next question is this, right? Number 15 from the 100 derivative video. So we have number 15. We will be differentiating. We have e to the 4x times cosine of x over 2. So let's just focus on this. Please help me out. What should we do right here first? What's the big picture? Yes, I can see your comments. You nerd math in Arabic, but you helped me so much. Thank you so much. Glad to hear that. We are going to use the product rule. Keep in mind, this is the derivative. This is not integration. If you do have an integral of this function, yes, you use integration by parts. Okay, here is the product rule because this times that. So the first thing is you keep the first function. So e to the 4x, and then we are going to differentiate the derivative of the second, right? We're going to multiply by the derivative of the second. Derivative of cosine is negative sign, sorry. Derivative of cosine is negative sign. And the input stays the same, so x over 2. But look at the derivative of the inside. Derivative of x over 2. X over 2 is the same as 1/2 times x. So the derivative of this is 1/2. You need to multiply by this 1/2 because of the chain rule. Then we are going to add the second function, which is just cosine of x over 2. And then we are going to multiply by the derivative of the first. Derivative of e to the whatever, right? E to the box is just e to the same thing here. And then multiply by the derivative of the inner part. Derivative of 4x is the 4, so we have a 4 right here. So that is what we have. And now perhaps we just clean up a little bit. For example, we can put a negative 1/2 to the front. So this right here gives us 1/2 negative 1/2 e to the 4x, and then we have sine of x over 2. And then we can put a 4 to the front, so we can say plus 4 e to the 4x, and then cosine of x over 2. You can also factor out the e to the 4x, but in my opinion, it's not necessary. You can totally box this for the answer. Done. So this is product rule with chain rule with exponential function and cosine function. I'm using tablet today. No more pen switching moment. I know, I'm sorry. I hope this is more clear. And yeah. Try to relax today. I feel like if I use iPad with this setting, it's more relaxing. So you guys should also relax and relax. Plus it's 1 a.m. If you guys can see that right now, it's 1 a.m. Okay, next page. Number 17. Right, that's number 17. Number 17, I prepared the derivative of inverse tangent of square root of x squared minus 1 for you guys. You are one of the only people who helped me improve in math. Thank you so much. Thank you too. All right, one thing you definitely have to remember is if you have the derivative of inverse tangent, and here it's like you have a box. Yeah. So I'll just put on, I'll put on like a box. So I should have say, this is DD box. Cool, huh? What you get is 1 over 1 plus a box squared. This is the derivative of inverse tangent. And now, here we go. We are going to have 1 over, and then we have 1 plus this thing, whatever it is in the box, but you put that in the parentheses. And then you have to square that. Just put this in the box, so it's like that. All right, then the derivative of square root. So I will put this down right here for you guys as well. I will put this down. This is the derivative of the inverse tangent of a box. You also should remember that the derivative of a box, if you have the square root of a box, this gives you 1 over 2 square root of a box. So here we have square root, and then we have the x squared minus 1 inside. It's like a box. So for the square root part is 1 over, and we are multiplying, 2 square root of that thing, which is x squared minus 1. Lastly, the derivative of x squared minus 1 is 2x. So multiply by 2x. So that's the right out. Now be careful with this. We see that the square and square root cancel, and the bottom here, this is 1 plus x squared minus 1, and of course 1 minus 1 is 0, so we have x squared. So let me write down the whole thing again for you guys. For the first part, we have 1 over x squared. Then we multiply by the next part, 1 over 2 square root of x squared minus 1. Lastly, we have the 2x. Aha! Yes, we can do some cancellations. 2 and 2 cancel. X and 1 of the x cancel. So, the final answer, I will put it down right here to save space. We have just 1 on the top. X times square root of x squared minus 1. And we're done. Yeah. Okay, so definitely remember the derivative inverse tangent and also the derivative square root. Okay, why don't we need the absolute value? Because square root of... Oh, so for this one though, technically we have square root of x and then square. You don't need the absolute value because based on how this is written, x has to be greater than or equal to 0. If you have square root of x squared, this right here is equal to x with the absolute value. But this right here is just equal to x. However though, you have to make sure that both of them x greater than or equal to 0 because how the expression is written. Yeah, so for this one we are good because it has the condition that the input x squared minus 1 has to be greater than or equal to 0. So that's nice. Yeah, cool. Now, next one, I prepared, one of my favorite ones, number 19, x to the x power. So, number 19, let's differentiate, oh sorry, that's a horrible looking d. There we go, much better. X to the x power. Ready? Okay, here we go. We don't like to differentiate if the base is a variable and the power is also a variable. So, check this out. We are going to rewrite the base with e, and to do so, let me just make a note right here on the side. We love to differentiate when we have base e. So for the x right here, we can actually write it as really just e, and then ln x power, just like this. And then if you want to get the derivative of x to the x power, x has to be greater than 0 for continuity purpose. So x has to be greater than 0 here. So we are good for that. Okay, so in such case, we can look at the base x right here and then replace that with this. So we are going to get the derivative of, here I will write down e to the ln x, and then I will just raise that to the x power, which we can really say that's just taking the derivative of multiply the powers together, which is e to the x ln x power. In my opinion, this right here is cleaner, but of course, some people will tell you write x to the x as y and then take the natural log on both sides. That's totally fine too. If you guys want to see another approach for this, check out my other video, or remind me, I will put another video in the description later on. But let's finish this. Okay, e to a box. First, we just have e to the same thing. Then we multiply by the derivative of the box. Here we need to use the product rule though. This is x times ln x. Product rule says, keep the first one, which is x, times the derivative of the second. The derivative of ln x is 1 over x. Then we add the second function, which is ln x, times the derivative of the first. Derivative of x is just 1, so that's what we have. Now, what is e to the x ln x? What's this part? This right here is just that. It's just that, which is x to the x power. And then this right here, x times 1 over x is 1. ln x times 1 is just ln x. So we are done. So I'll pause this right here for you guys. This right here is really meant to be for calculus 1. But of course, once you get to calculus 2, you should still remember how to take the derivative. Right? Take a look. And after that, I'll get ready for the next one. Right, for the next one, I want to have more space. So here we go. Number 30. Here we have to do an implicit differentiation question. All right. So we have 9x squared plus y squared, and that is equal to 9. And we want d2y dx2. Here we go. Notice the y is not isolated, so let's just do implicit differentiation. Go ahead, d dx this, and draw the equation. Now, for the first term, we can just bring the 2 to the front and then minus 1, so we get 18x. But for the next one, we bring the 2 to the front, minus 1, we first get 2y. However, we will have to multiply by the derivative of y with respect to x. And that's exactly how we get the dy dx here. Then the derivative of 9 is just 0, so this is equal to 0. Then move the 18x to the other side. We have 2y dy dx equal to negative 18x. And then right here, let's divide 2y on both sides. So we are getting dy dx equal to negative 9. Let me write it down on the top. Yeah, negative 9. And then the x, and then the y. Okay, so take a look. Let me know if you have any questions. Yeah, put it down right here like this. We are not done yet because we are trying to get d2y dx2, and that is the second derivative. And for the second derivative, we are going to take the derivative of the first one. So have a look. This right here literally saying take the derivative of the first one. And that's why we have the 2 right here, because the d and d. And that's why we have the 2 right here, because the dx and dx. In my opinion, the derivative notation is the, how should I say it, the most well-designed notation in mathematics. It's just so smart how they come up with such a notation. So, let's see. For d2y dx2, I'm going to just write down our dy dx, which we got it, which is negative 9x over y. And then I will just have to differentiate this with respect to x again. On the left-hand side, we get precisely d2y dx2. On the right-hand side, yes, we are going to use the quotient rule for the first time of the night. I'm going to square the bottom function before I forget. So we have y squared. And then I'm going to bring up the bottom function here and multiply by the derivative of the top. Derivative of negative 9x is negative 9. And then remember, we are going to subtract. Subtract the top function, which is negative 9x. And then multiply by the derivative of the bottom. Derivative of y is precisely dy dx. So this right here is because of the quotient rule. So have a look carefully. Now notice here we have dy dx, and we saw that that is equal to just negative 9x over y. We got that earlier, right here. So we can put that back for this. So d2y dx2, we can look at this as negative 9y plus 9x times negative 9 x over y, and then over y squared. Whoa, it's like this expression is kind of big, huh? Okay, have a look next. We don't like to have complex fractions, so let's multiply the top and bottom by this denominator. So let's multiply y and y. So for the bottom, we will get y to the third power. For the top, make sure you do y times this term, which gives us negative 9y squared. And then when we do y times this, here, y and y cancel. And then worked out this. 9 times negative 9 is negative 81. X times x is x squared. And now I will zoom out so you guys can see everything. But there is one thing that we can still do. There's one thing that we can still do. So take a look and drop in the chat and let me know if you see anything that we can possibly do to continue. The 9? What do you mean the 9? What can we do with the 9? Aha, yes. Notice that we know that 9x squared plus y squared is equal to 9. Right here, we can factor things out. So let's just focus on this. Here, on the top, we can factor out a negative 9, and then we get y squared. Negative 81 divided by negative 9 is plus 9. And then the x squared over y to the third power. And then, have a look. Originally, we have this, isn't it? 9x squared plus y squared is equal to 9, and that is exactly what we have here as well. So we can put the 9 right here. So we will get negative 9 times this 9, and this 9, and then over y to the third power. And then finally, we can just say the answer is negative 81 over y to the third power. Whew. One of the longer ones. By the way, this is a classic Calculus 1 differentiation question, implicit differentiation question. For the second derivative, can I differentiate 18x plus 2y dy dx equal to 0? Hey, that's a great idea. I did not thought about that. I did not think of that. The downside here is that you have to use the product rule. I think it will work. It definitely will work, but I'm just not sure about if it's easier, maybe because we don't have to use the quotient rule. And yeah. Yes, you can also just look at this and differentiate. Okay, let's do the next one. I try to pick all kinds of functions for you guys, and here we have 10 examples. Next one, we'll do the second derivative, and then we have ln of cosine x. So number 39 from my 100 derivative video. Oops, is d2 dx2, meaning the second derivative, ln of cosine of x. So here we go. This really means d dx and then d dx and then ln of cosine x, like this. You don't have to rewrite it though. But anyway, I'm going to keep the first d dx, and then let's focus on the inside here. I'll do this one in blue. take the derivative of natural log something, and perhaps I will remind you guys right here real quick, take the derivative of natural log of a box. Yeah, this right here gives you 1 over the box. So here we have ln of the cosine function. So it will be 1 over cosine. 1 over cosine x. Then we multiply by the derivative of cosine x, which is negative sine x. So in fact, you just have to differentiate sine over cosine is tangent, and that's negative. So the derivative of tangent x equals negative secant. Oh, I should have asked you guys for the answer. The derivative of negative tangent x is negative secant x. Negative secant square x. Oh, Hassan got it actually. Yeah, you got it before I asked. Excellent. Right, next one. Right, quotient rule, and then one more ln, and then we'll be done. So number 42. So dx, and then here we have square root of all that stuff. So let me just write it down real quick. Square root of x squared minus 1 over x. I should have titled this as calculus 1. You still need to know this derivative for calculus 2 though, especially some quotient rule, product rule, and all that. But anyway though, let's get started right here. Quotient rule in action. I'm going to square the bottom function right away, and then I will have the bottom function here times the derivative of the top. Okay, the derivative of square root of x squared minus 1, be careful, this is 1 over 2 square roots of whatever the inside is. And then look at the inside. The derivative of x squared minus 1 is 2x. So you multiply by that, and you can cancel out the 2. So that is x over square root of x squared minus 1. And that goes right here. So multiply by x over square root of x squared minus 1. Then we are going to minus the top function, which is square root of x squared minus 1. And then we are going to multiply by the derivative of the bottom, which is just 1. So that's pretty much the derivative. And to simplify this, let's just multiply the top and bottom by this denominator. So square root of x squared minus 1. And let's also multiply that by square root of x squared minus 1. So have a look. Here, when we do this times that, the denominator and that will cancel. So we just have x squared. This times that, the square root will cancel. So it's minus parentheses x squared minus 1. Over, here we have x squared. Here we have the square root x squared minus 1. Now just work this out. This is the same as x squared distributed, so minus x squared plus 1 over the denominator. And then we see that this and that cancel. So final answer, 1 over x squared, square root of x squared minus 1. Done. Black pen, red pen, calculus basics. Did you break your whiteboard by tapping it too hard? No, it's just so that I can like write down all the steps for you guys today. Yeah, my whiteboard is still going strong, so no worries. That's number 42, and then let's do two more, just two more. So I'll do this right here, number 62. So the dx of, here we have sine x minus cosine x over sine x plus cosine x. All right, without further ado, here we go. Quotient rule in action. I'm going to square the denominator first before I forget. Then I'm going to bring the bottom function up here, which is sine x plus cosine x. Then I'm going to multiply by the derivative of the top. Derivative of sine is cosine. Derivative of negative cosine x. This gives us positive sine x. Then we have to subtract the top function, which is sine x minus cosine x, and then multiply by the derivative at the bottom, which is cosine and then minus sine. Alright, so for this one right here, I'm just going to work it out. That's all. So for this one, in fact, the first one is actually just a binomial, but I will just do the usual way. So have a look right here, right? Sine x times cosine x is sine x cosine x, and this times that is plus sine square x, and then this times this is plus cosine square x, and this times that is plus 2 sine, sorry, is cosine sine, so let's put the sine down right here first. Yeah, this times that. Cool. Now for the next one, okay, I'm going to minus, and then let's multiply this out. So sine x times that is sine x cosine x, and this times that is minus sine square x. This times that is minus cosine square x, and finally plus sine x cosine x. Whew, all over. You can actually simplify this a little bit before you multiply it out, but I think this is what most people might just do, so I will just do it like this. Just multiply it out. So now, have a look right here. Minus this and that, we can write it as minus sine square plus cosine square. So this is just minus 1. Yeah, that's equal to 1. So in fact, here, we also have 1. Yeah? So we can actually combine a lot of stuff. Check this out. Firstly, we see that sine x, cosine x, sine x, cosine x, so together we have 2 of them. And then plus 1. Yeah, so this and that is that, and then the 1 right here. Then we are going to minus, here we have sine x, cosine x, and then another 1. So that's minus 2 sine x, cosine x. Lastly, we are going to minus a negative 1, so it becomes a plus 1. Yeah, minus negative 1. Okay, over sine x plus cosine x squared. And now we can be happy because 2 sine cosine x minus 2 sine cosine x, they cancel. And then the top though, 1 plus 1 is 2. So we get 2 over, I'm just going to write that down right here, sine x plus cosine x, and then we square that. And we are done. Alright, so that's number 62. Alright, final question of the day, number 79. I realize there is a small problem with this setup. I think you guys can let me know what you guys think about it too. It's that whenever I write, the camera will focus on my hand, so this thing is not going to be focused. So it might be kind of blurry, kind of like making you dizzy. I'm sorry. I don't know how I can fix that. I really want to just kind of project from my iPad so I can just write it like this. Alright, anyway though, here we go. One of the classic calculus 1 derivative question. You definitely have to know this. Let's just cut to the chase. The derivative of ln of a box. Yeah, it's 1 over whatever the box is. Then we are going to multiply by the derivative of the box. Derivative of x is equal to 1, and then we add the derivative of square root. Now, the derivative of square root is 1 over 2 square root of whatever that inside is. So we have that right here. Now, here's the common mistake. I have seen students, they close the parentheses and then they multiply the derivative of this, which is the 2x. This is incorrect. Because the 2x is the chain rule from the square root part. So it should just be right next to the 1 over 2 square root of 1 plus x squared. Do not have the parentheses. So it should have been multiplied by the derivative of this, which is 2x. So multiply by the 2x right here, and then you close the parentheses. This whole thing is the derivative of the square root function. Alright, then we can cancel out the 2, that's kind of cute. And then for this, I'm going to combine the fractions. So I'm going to write down the front part again. For the 1, pay attention to the 1 right here. The denominator is square root of 1 plus x squared. So change the 1 to square root of 1 plus x squared over square root of 1 plus x squared. And then we can plus x over that. Now they have the same denominator, so we can just put the top together, and you'll see that 1 over x plus square root 1 plus x squared. We multiply that by this plus that over this. Okay, what do we see? Is this exactly the same as that? The order is different, but the order of addition doesn't matter. So we can really just cancel this and that together. Finally, the answer is just a 1 on the top over that on the bottom. Yay! So that is number 79. Alright, thank you guys so much for coming today. Let me know how you like this format. Alright, and until then, I'll see you guys next time. Next time, we'll do limits. Bye!